EDX Decision 1, Algorithms, Sorting, Packing and Other Algorithms. Bin packing algorithms. The bin packing problem deals with packing boxes of the same width and depth but different heights into a series of bins. The algorithm can then be applied to a whole range of applications. So for example, here are the bins of fixed height that we're trying to fill, and these are the items we're trying to fit into the bins as efficiently as possible. So it's the height of the items that's important. So one way of doing this is called the full bin combinations. So we simply look at the items and we look for combinations that will fill a bin. So we're looking for full bins. So the heights of these bins are 12 and these are the various items we're trying to pack. So by inspection we realise that the 4 and the 8 will fill a bin. We might realise that the 7 and the 5 will fill another bin. Then the 10 and the 2 will fill a bin, and the 8 and the 4 will do likewise. So that's an example of the full bin algorithm, which is fine if you've only got a few items, but if you've got perhaps dozens of items, it would be far too complicated to do it by using a full bin algorithm. So the next algorithm we're going to look at is called the first fit algorithm. And the premise now is that you do them in the given order, the items in the given order, and you always put the item in the first available bin that it will fit. So 4 is the first item, and that will fit in the first bin. 8 is the next item, and that will also fit in the first available bin. Then 7 can only go in the new second bin. 2 can also fit in the second bin. 10 obviously has to go in the third bin. 8 obviously has to go in the fourth bin. 4 can also fit in the fourth bin. And 5 will be on its own in the fifth bin. So that's the solution using a first fit algorithm. The first fit algorithm is a heuristic algorithm, which means that it attempts to find an optimum solution, but it's not guaranteed to be an optimum solution. It's fairly easy to carry out as a procedure or to program into a computer. It can, however, be a little inefficient. How might we improve this algorithm? Well, one way of improving the first fit algorithm is to make it a first fit decreasing algorithm. So instead of taking the items in the given order, you first use a sorting algorithm to put them into descending order. So an exam question may ask you to do the sorting algorithm first and then the first fit decreasing algorithm afterwards. So now we've got them in descending order, we always put an item in the first available bin. So 10 will fit into the first bin, 8 must go in the second bin, the next 8 must go in the third bin, the next 7 goes in the fourth bin, 5 however will also fit in the fourth bin, and this is the one that some people miss. The next 4, the first available bin is the second one, and the next 4, the first available bin is the third one, and 2, the first available bin is bin number 1, and we can see that that solution is more efficient than the first fit algorithm. Bin packing algorithms can be applied to a range of contexts. For example, cutting lengths of wood for DIY, or cutting strips of wallpaper, recording videos onto videotapes, or putting files onto CD-ROMs, or parking vehicles in appropriate ferry lanes ready to embark on a ferry. There's no guarantee of getting an optimum solution. The first fit decreasing algorithm is often, but not always, more efficient than the first fit algorithm. So here's an example. We've got 11 items as follows, and we need to fit these items into boxes that can contain 12 kilograms. So we've got various masses of items, and we have to fit them into a maximum weight of 12 kilograms in each box. So the first thing we're going to do is part 1, which is a first fit algorithm. So I do them in the given order. So 2 will fit into the first box. The next 2 will fit into box number 1. 3 will fit into box number 1. The next 3 will also fit into box number 1. 4 will have to go into box number 2. The next 4 also goes into first available box, which is box 2. The next 4 also goes into box 2. 5 will need to go into box 3. 7 will also fit into box 3, just. The next 7 will need to go into box 4. And the last 7 will not fit in any other box and therefore will need to go into box number 5. So if we look at our use here, so we've got 10 kilograms, 12 kilograms, 12 kilograms, 7 kilograms, 7 kilograms. So the question is, can we find a better solution using the first fit decreasing algorithm? So this time I'm going to start with a 7 at this end and work my way down to the 2. So I start with the biggest item. So starting with the 7 this time. So 7 goes into the first box. The next 7 has to go into box 2. It won't fit into box 1. The next 7 will have to go into box 3. Then we're on to 5. 5 will fit in box 1. The next one is 4, which will fit into box 2. The next one is 4, which will fit into box 3. And the next 4 will have to go into a new box 4. Then we have 3, which will also fit into box 4. And 3, which will also go into box 4. Then the 2, the first available box it will fit in is box number 4. And the last 2 will need to go into box number 5. So if we look at how heavy these boxes are now, we have 12 kilograms, 11 kilograms, 11 kilograms, 12 kilograms, and 2 kilograms. So the question is now, can we improve this solution even further? So we're going to try and improve the solution by using a full bin algorithm. So now we're looking for combinations of bins which will go together to make 12 kilograms. So I don't need to do them in any particular order. So for example, I might spot the 7 and the 5 will go together to fill a bin. Then I can put a 7 with a 3 and a 2 to fill the next bin. Then I can put the next 7 with a 3 and a 2 to fill bin number 3. And finally, I could put all the 4s together to fill bin number 4. Now if we look how heavy the bins are, we've got 12 kilograms, 12 kilograms, 12 kilograms, 12 kilograms. So in this simple example, the full bin algorithm created the most efficient solution. In the next session, we'll be looking at sorting algorithms, starting with the bubble sort algorithm.